There are 15 girls and some boys among the graduating students in a class. They're planning to get together, which can be either a 1-day event or a 2-day event or a 3-day event. And so, girls and boys, 15 of them, some X of them, 1 day, 2 day, 3 day. There are 6 singers in the class, 4 of them are boys. There are 10 dancers in the class, 4 of them are girls. So singers, 4 boys and 2 girls. Dancers, there are 6 boys and 4 girls. Nice. Boys and girls we don't know. Singers, there are 4 boys and 2 girls. Dancers, there are 6 and 4. We don't know how many boys are there totally. We just captured the data, nothing more. There are many more layers to this. It's a actors. Some students are not interested in attending the get together. Those students who are interested in attending a 3-day event are also interested in attending a 2-day event. Those who are interested in attending a 2-day event are also interested in a 1-day event. So 3-day event, 3-day event, 2-day event, 1-day event, and then there are people outside of this. This is a subset of this, a subset of this. 3-day, 2-day, 1-day, and outside. There are some number of people here as well. So this is like a Venn diagram, a nested subset thing. Right? So, and there are going to be boys and girls in each of them. And then this complicated singer dancer thing is also going to come. And already I'm not that comfortable because there's one hierarchy which is 3-day, 2-day, 1-day, and none at all. And there is boys and girls. And then there is singer dancer somewhere in the equation. Right? So we don't even know how many boys are there totally. Right? Interested in 3-day events, 2-day events, 1-day event. I originally drawn circles and it didn't work out well. Raghu had the idea of doing it like this. It looks much better. Right? So thanks, Raghu. Super. And then we come to other conditions. So we layer it on and say for each of this 3-day, 2-day, 1-day, we could have dancers and singers, neither dancer nor singer. So we have layers of classifications. Some of these will probably never get the detail, some we may. Let's see where it goes. And now let's go to the conditions. All the girls and 80% of the boys are interested in attending a 1-day event. All the girls and 80% of the boys. That is 20% of the boys, which is 0.2x, is outside. This is 0.8x. This is all boys. Number of girls, 0. Who are not interested in attending is 0. All the girls are interested, so this outermost should be 15 totally. Singers, dancers, neither, all put together. This is 0.2x, we're talking about integers. So this is 1 by 5x. 1 by 5x should be an integer, or x should be a multiple of 5. And so it could be 5 and 1 or 10 and 2. Obviously there are at least 10 boys. So we're talking about 10, 15, 20, 25, 30, one of those numbers. X is a multiple of 5, because there's a 0.2x involved here. Nice, let's go to the next condition. Some of the girls are interested in attending a 1-day event, but not a 2-day event. So there are some number here for girls, not here, but here. 1 day, but not a 2-day event. Some of the other girls are interested in attending both. That is, some numbers come here or here, both 1 day and 2 day. So inside 2 day there are a bunch of numbers, not 0. This is not 0 either. Outside is 0 for girls, that much we know. 70% of the boys who are interested in attending a 2-day event are neither singers nor dancers. So we're interested in attending a 2-day event. Of the boys, 0.2x goes away here, 0.2x goes away here. So we have 0.6x remaining for 2-day event. 70% of them are neither singers nor dancers. I mean, 30% of them are singers / dancers. So if you think about singers / dancers, we think about this whole region. This whole region, singers and dancers, boys, that should be 0.18x. 30% of 0.6x. 70% are neither dancers nor singers. That means the remaining are dancers or singers. We already know that singers and dancers, there's no overlap. That's very clear, been given. 60% of the girls who are interested in attending a 2-day event are neither singers nor dancers. So 2-day event, 40% of them would be singers or dancers. 40% would be singers or dancers. So this singer and dancer put together is 40% of the total number. 40% is 2 by 5. The total number for the 2-day event should be a multiple of 5. Total number of girls should be a multiple of 5. And this number here, all put together, singer and dancer, is 40% of something. So it should be a multiple of 2. This is 0.18x. 0.18 is 18 by 100. Or 9 by 50 of x. 9 by 50, that means x should be a multiple of 50. Otherwise, this won't be an integer. If x were 50, this will be 9. If x were 100, this will be 18. We know the total singers and dancers is just 10. So x cannot be 100. X has to be 50. That's brilliant. The total number has to be 50. That means this is 10 here. This is 10 here. This number is 9. Singer and dancer put together for 2-day event, which includes the 3-day event, is 9. Singer dancer put together. Brilliant. 60% of the girls who are interested in attending a 2-day event are neither singers nor dancers. That we'll probably use a little later. 40% are singers or dancers. Now we know that this is 9, this is 10, this is 10. The total number of boys is 50. Not much more. No girl is interested in attending a 3-day event. 3-day event is 0, 0, 0. Brilliant. That means there should be quite a few number here within the 2-day event, that region. 2-day but not 3-day, there should be some number. All male singers and 2 of the dancers are interested in attending a 3-day event. All male singers. How many male singers are there? 4 male singers are there. So let's draw a line here. Make this 4. And 2 of the dancers. Dancers have to be male because female is 0. 2 of the dancers are here. Brilliant. So overall there is 9. All male singers are taken. Overall 9. So that means if I extend this, this should be 0. That all male singers are sitting here in the 3-day event. Only 2-day but not 3-day, that should be 0. This is 4, this is 2. 4 and 2. So I'm taking off this 9 and putting 3 here. Brilliant. So male singers should be 0 and 4. Only 2-day, 3-day also. And 3 and 2. Only 2-day, 3-day also. Brilliant. And this is 0, 0, 0. How many girl singers are there? 2 girl singers are there and 4 girl dancers are there. She'll have to figure that out. The number of singers interested in attending a 2-day event is 1 more than the number of dancers interested in attending a 2-day event. Singers in a 2-day event, singers would be 4 so far. Dancers would be 5. Number of singers is 1 more than the number of dancers. This is 5, singers should be 6. This is 6, singers should be 7, and so on. And so the 2-day event, there are 5 dancers already included from boys. See, the number of singers interested in attending a 2-day event is 1 more than the number of dancers. So dancers is 5. Singers could be 1 more than that. It could be 6. Means this could be 2. This could be 0. That's a possibility. Or we could have more than 2 singers with dancers also coming in there. But we have only a maximum of 2 girl singers. We have only 6 singers with us. We already have 5 dancers. So the number of singers has to be 6. So this should be 2. Which means this should be 0. Nice. Lovely. So we filled this out rather well. Let's continue with this. 60% of the girls who are interested in attending a 2-day event are neither singers nor dancers. Singers or dancers is only 2. That is 40% of the total people who are interested in doing a 2-day event. That means if this is 2, this has to be 3. Totally 5. 40% here, 60% here. Neither singer nor dancer should be 3. The 4 dancers among girls. There is no girl that is outside, that we know. So all 4 dancer girls should be in this region, not this. This is 0. So 2 plus 4, 6 plus 3, 9. Everything is filled, so this should be the remaining 6. That also we can fill. 15 girls are there totally. Now we fill the entire grid. Very interesting question, but properly challenging. I struggled and struggled and struggled for this because there are classifications between boys and girls. And there is day 1, day 2, day 3 nested subset structure. And then singers and dancers for boys, singers and dancers for girls. Given that we grab onto this way of presenting data and then simplify and do it methodically, it seems easy. It's a properly challenging, tough question. Let's attack the question now. This how many boys are there in the class is easy. 50. It should be a multiple of 50. 100 doesn't work. 50 works. Done. Which of the following can be determined from the given information? The number of boys who are interested in attending a one-day event and neither dancers nor singers. One-day event, neither dancers nor singers. Let's see this. So how many? 5 dancers are already taken. There's 1 dancer remaining. 4 singers are already taken among boys, but there's 1 dancer still remaining. That could be here or here. So I don't know where that missing dancer is. Is the person who wants to attend a one-day event but not 2-day or 3-day, or who does not want to attend any of this, quite happy sitting outside? We do not know that yet. So statement 1 cannot be handled. We cannot answer this question. So if we have 1 missing dancer, that person could be here or here, right? The totally 6 boy dancers, 5 we have accounted for, 1 still missing, therefore we cannot answer that. The number of female dancers who are interested in attending a one-day event. Female dancers, one-day event, 4, that can be answered. 2 can be answered, 1 cannot be answered, only 2. What fraction of the class are interested in attending a 2-day event? 2-day event is this circle. This 10 goes off, that 10 goes off. 10 plus 10, 20 is gone. This 10 is gone. 30 is gone. So the remaining, totally there are 50 plus 15, 65 people, 50 boys and 15 girls, 65 people, of which this 10 is out, this 10 is out, and this 10 is out. 30 is out. 35 are interested in attending a 2-day event, which includes the part which is interested in attending a 3-day event also. So 35 by 65 are interested. So 2 plus 3, 5 plus 4, 9 plus 2, 11 plus 3, 14 plus numbers here that need to come in. So remaining is 35, 35 by 65, 7 by 13, done. What best can be concluded about the number of male dancers who are interested in attending a one-day event? Male dancers, 5 are there for sure. 6th one, that missing one, could be here or could be outside. The number of dancers who are interested in attending a one-day event but not a 2-day event, that sliver, could be 0 or 1, or the total could be 5 or 6. We cannot say for sure that it has to be 5 or it has to be 6. 5 or 6, both are possible. How many female dancers are interested in attending a 2-day event? 2-day event is this, including this. Female dancers, 0, 0 for sure. We know that 0, 0 for sure. 0, yeah. 3-day event and 2-day event. 2-day only, 2-day but not 3-day and 3-day. This whole thing is 0, 0, 0, 0 totally. Lovely set, super challenging, even though the solution kind of looks doable. Super tough in an exam context. Given above is the schematic map of the metro lines in a city, which with rectangles denoting terminal stations, diamonds denoting junction stations, and small filled up circles denoting other stations. Look at the diagram. Terminal, junction, and other stations. Each train runs either in the east-west or the north-south direction, but not both. Nice, they don't do this. All trains stop for 2 minutes at each of the junction stations on the way and 1 minute at each of the other stations. It takes 2 minutes to reach the next station for trains going in east-west direction and 3 minutes for north-south direction. So here in this direction, it is 3 minutes between stations. In this direction, it is 2 minutes between stations. 1 minute stop at normal stations, 2 minutes at junction stations. From each terminal station, the first train starts at 6 a.m. The last trains leave the terminal stations at midnight. Nice. Otherwise, during the service hour, there are metro service every 15 minutes in the north-south line, every 10 minutes in the east-west lines. North-south is every 15, east-west is every 10. So there will be a train starting at 6, at 6:10, at 6:20, at 6:30 from here and here, and at 6, 6:15, 6:30, 6:45 and so on here in this axis, both directions. A train must rest for at least 15 minutes after completing a trip. It's tired. Before it can undertake the next trip in the reverse direction. So come from P to Q, I think, and then go back from Q to P. All questions are related to this metro service only. Assume that if someone reaches the station exactly at the time of a train is supposed to leave, he or she can catch a train. The train is leaving at 10:58. I run in, I can get it. Somebody will pull me in rather climactically, wonderfully. And so, nice. And all trains stop for 2 minutes at the end of the junction stations on the way and for 1 minute at each of the other stations. So 2 minutes at junction, 1 minute at others. Just capturing the data. And 2 minutes between stations, train every 10 minutes. 3 minutes between stations, train every 15 minutes. This is the east-west equation, the north-south equation. Right. So just grab the data on, we can't really solve anything and simplify and get a grid and answer. We have to jump through to the questions. First train start at 6, last trains at midnight. If Hari is ready to board a train at 8:05 a.m. from station M, then when is the earliest he can reach station N? M to N. From M to N. 8:05 he is ready to board here at station M. What is the earliest he can reach station N? Right. Nice. So he'll take the straight train here. Right. All we've got to do is, he can't catch it at 8:05. He'll probably grab it only at 8:10. That's when the first train. First train leaves at 8. Second train will leave at 8:10. Because train every 10 minutes in the east-west axis. 2 minutes between stations. I'm going to calculate this. So there are 3 stations here. Say 3 here. 1, 2, 3, 4, 5, 6, 7, 8, 9 here. 1, 2, 3, 4, 5, 5 here. 3 plus 9, 12 plus 5, 17. Plus 2, 19 stations. So 20 gaps from first to end. 20 into 2, 40 minutes. Just a travel time. Nice. Now we need to think about waiting time. How much time does it take to wait? 3 plus 9 plus 5. This is 12 plus 5, 17 minutes of waiting. 3 plus 9, 12 plus 5, 17 minutes of waiting. Plus 2, 4 minutes of waiting. Just 21 plus 40, 61 minutes. So the moment he boards on to this, 61 minutes later he can reach there. What time does he board on? He can't get on board at 8:05. The earliest he can get on board is 8:10. 8:10 plus 61 minutes. 8:10 and 60 minutes is 9:10. 61 minutes is 9:11. Nice, simple, juicy one to get out of the way, to get comfortable with this. Now we have to register these numbers. 3 stations here, 3 here, 9 here, 5 here, and then we do from one chunk to another. How long does it take to travel? All of that. And so 2 minutes between stations in this axis, 3 minutes between stations in this axis. If Priya is ready to board a train at 10:25 from station T, what is the earliest that she can reach station S? From T to S. Right? She is boarding at 10:25. She wants to reach station S. Right? First of all, she can either go like this and then like this, or like this and like this. Right? I'm going to think in terms of what will be the train that comes to T first. right? But before that, I understood that there are 9 stations here, right? So we can say T to V, how long does it take? In between 2 minutes between stations, 10 such stations, 10 to 20, 10 such distances, 10 to 20, plus 9 waiting times. This stretch takes 29 minutes. This stretch 1, 2, 3, 3 into 3, 9 plus 2, 11 minutes. This stretch 1, 2, 3, 4, 4 into 3, 12, 12 plus 3, 15 minutes. This stretch 1, 2, 3, 4, 4 into 2, 8, 9, 10, 11, 11 minutes. So we can calculate each of these stretches and keep them because we are going to use them in some form or other. First of all, we are going to think about from T to S, is it TVS or TRS, which is better? Right? For which we need to find the train that comes to T because it's at 10:25. And so P to T is 11 minutes. Starting at here, a train starts every 10 minutes. So at 8, there will be a train starting. At 8:10, there will be a train starting. At 8:20, there will be a train starting. So train going in this direction will come at 8:11, 8:21, 8:31. The earliest in this direction is 8:31. This way, how does it work? There will be a train starting at 8 and then 8:15. This stretch again is 11 minutes. We computed that. So it's 8:11 or 8:26. If it is 8, it is 11 and 26. If it is 10, 10:25, it's 10:11 and 10:26. Straight away, I know that if I go like this, I start at 10:26. If I go like this, I start at 10:31. I've written 8. I'm going to remove that. I'm going to simplify that for myself. (10:31), whereas this axis is 10:26. 10:26 seems juicier, so I'm going to go with that. I'm going to start with that. So with the 10:26, then this stretch takes 15 minutes. Why? 1, 2, 3, 4. 4 into 3, 12 plus 3 waiting times, 15 minutes. So it comes here at 10:26. He boards that at 10:26, which is rather nice. And then it's a 15-minute stretch, but there's a 2-minute waiting time at T. T is still a junction station, not a terminal station. So I start at 10:15. I arrive at T at 10:26. I leave from T at 10:28. Take 15 minutes to reach this point. 10:28 plus 15, 38, 10:43. So I'll be here at 10:43. And then I'll have to take a right and go along that direction. That is my TRS route. And so from 10:25, I board at 10:26. It leaves at 10:28 plus 15, 10:43. I'm here, which is rather nice because my train in this direction will come at 10:41. Will wait for 2 minutes. So at 10:43, I come. I can still board the train. So at 10:43, I'll board at R, which is brilliant, which is super useful for me because now I know there's no waiting time at R at all. So I can ignore this route. As it is, I'm 5 minutes behind. There's a long waiting time at R. I'll have to worry about, is there a shorter waiting time at V? No, I don't wait because there's no waiting time at R. This is my preferred route. At 10:43, I leave from R. From R to S is 29 minutes. How do I know that? 10 into 2, 20. 10 distances of 2 each, 20. Plus 9 stoppages. At 10:43, I leave from R. I board R at 10:43. I leave from R at 10:43 because it has come to R at 10:41. From 10:43, 29 more minutes, I'll be at S and I need to reach S. 10:43 plus 29. 10:43 plus 17 is 11 o'clock. Plus 12 more. 11, 12. I can expect to be here. My route is TRS because my BT train comes within 1 minute of reaching, whereas my PT train takes 6 minutes. So I can start sooner if I come here. And if I take this option, I'm practically not waiting at R. I get out of my station, run in, board the other station and head out. So both ways it works brilliantly. So 11, 12 is the answer I'm looking for. Hopefully that will be there in the choices. It is there. Haripriya is expected to reach train station S late. I didn't understand this question. Late as in what late? What is 2 a.m. late or 6 p.m. late or 11 a.m. late? What is the latest time which we must be ready to board at S? If she must reach station B before 1 a.m. via station R. So she has to come here and come here. She has to reach B before 1 a.m. This question is basically saying work backwards, right? This is 1 a.m. I know this stretch is 11 minutes. This stretch is 15 minutes. 11 plus 15, 26 plus 2 minutes waiting time here, 28 minutes. From the moment I'm at R, 28 minutes I can reach here. And so if I want to reach here by 1 a.m., I need to be at R by 12:32. I need to board by 12:32 because 15 minutes of travel plus 2:17 plus 11:28, I'll reach by 1 sharp. 12:32. The last train from here leaves at 12, which will come here at 12:11. There is no 12:32 train to go from A via R to B. It's not possible. So forget about that. So the 12:32 timeline is ruled out. I won't reach at 1 a.m. I'll reach a little sooner than 1 a.m. I have to, otherwise I'm in trouble. So what is the last moment I can board this train at R? R is 11 minutes from A. So 12:11 is when the last train comes here. So if I can board that train, then I'm reaching way before 1. And I cannot catch a train after that because there is no train starting after that from A towards B. So the train that arrives here at 12:11, that's the one I want to grab. Right? Or if I think about it slightly differently, I have to be at R by 12:11 to 12:13. Why? Because this train ARB will wait for 2 minutes at R. So even if I reach by 12:13, I'm fine. So my aim now is to reach R by 12:13. She must be ready to board at station S. So we are looking to board the NSRM train at station S, looking to be here by 12:11 or latest by 12:13. 12:11 is it? I want only the latest time, like I'm playing with the margins. So from S to R is 29 minutes, that I know. So 29 minutes before 12:13 is when I have to board. 12:13 minus half an hour is 11:43. 29 is 11:44. If I board from here at 11:44, at S I get out, I board at 11:42 or at 11:44, it leaves S. It leaves S at 11:44. Then I'm still covered because I leave at 11:44. 29 minutes I take, it will be 12:13. 16 plus 13, 29. 12:13, it is about to leave from R. I can reach here. That's the last train leaving at R. So leaving at 11:44 from S, I'm still covered. Right? So N to S is 17 minutes. On this axis, we have a train every 10 minutes. So we have a train coming at 11:7, 11:17 at S. And at N, leaving at 11, 11:10, 11:20, 11:30, plus 17 minutes, 11:17, 11:27, 11:37, all of that. So a train coming at 11:37 to S, I should catch. 11:47 at S, I can't catch. So I'm looking to catch the 11:37 train at S. What is the latest time which we must be ready to board on station S? The 11:37 train, but not 11:37, but 11:39, because it is going to come at 11:37 here and then wait for 2 minutes. Let it become 11:39 and then reach here and then come back here. And so there's no constraint here because I'll reach way before 1 a.m. This constraint here, I should be before 12:13. I start any time before 11:44, I'm good. The train arrives there at 11:37. I cannot catch 11:47, I'll be late. I'll have to catch 11:37, but I can catch 11:37 at 11:39. I catch at 11:39, I'll be here on time, I'm through. The last time you can reach by is 11:39 p.m. What are the minimum number of trains that are required to provide the service on the AB line, considering both north and south directions? Oh, nice. AB line, start from A. think about going to B. Let's think about how long it takes. Right? So this is 11 minutes. This is 15 minutes. This is 11 minutes. 11 plus 15 is 26. 26 plus 11 is 37. 22 plus 15, 37 minutes of this leg, this leg, this leg. What am I missing here? I'm clearly missing a 2-minute wait time here and a 2-minute wait time here. So 11 plus 15 plus 4, 22, 37, 41 minutes, which is brilliant. So 41 minutes and I can go from A to B. The train needs a 15-minute wait time before it can start functioning. So 41 plus 15 is 56. So if I start a train at 6 a.m. here, that train is ready to start from here at 6:56. Not before that. It'll reach here by 6:41, but at 6:56 he's ready to go back. Not before that. He needs just 15 minutes rest. So my 6 a.m. train should start from here. From starting from B, my 6 o'clock train will start. There's a train every 15 minutes here. My 6:15 train has to start. There has to be a new train. My 6:30 train has to start. That's a new train. My 6:45 train has to start. That's a new train. My 7 a.m. train can be the train that started at A. That means from B, I'll need 4 trains to start before the first train from A comes here and is ready to leave. Not just comes here, it should also be ready to leave. So 6, 6:15, 6:30 and 6:45, I should be ready to start from B before the guy who came from A to B is ready to fire and go. So 4 trains I need to go from B before the first train from A to here is ready to reinforce. Likewise, 4 from here, 4 plus 4, 8 trains are required. Are required to provide the service in the city for A, say, for the AB line, how many trains are required? 4 plus 4, 8 trains required totally. What is the minimum number of, say, what is the minimum number of trains that are required to provide the service in this whole city? The AB line is 8 trains. The CD line is 8 trains. These two we have done. If we can crack this, we are through. Multiply that by 2, we are through. Right? From P to T is 11 minutes. T to V is 29 minutes. V to Q is 17 minutes. That's 17 there. So 11 plus 29 plus 17 plus 4. 2-minute waiting time here, 2-minute waiting time here. Add all of this up. 11 plus 29 is 40. 40 plus 21 is 61. Apart from this, there's a 15-minute wait time. So from P to Q is 76 minutes. Or the train that starts from P at 6 a.m. is ready to start from Q at 7:16. 60 plus 16. Oops. So from Q, we need to have a train starting at 6, 6:15, 6:30. Here it starts every 10 minutes. 6, 6:10, 6:20, 6:30, 6:40, 6:50, 6:60, which is 7, 7:10. The 7:20 train can be this one. So 76 minutes or 8 trains. We start from 0, 0, 10, 20, 30, 40, 50, 60, 70. 8 trains need to start from Q before the first train that happened to start from P is ready at Q for the return journey. So this 8 from here, 8 from here. This line requires 16. This line requires 16. 16 plus 16 is 32. 8 plus 8 is 16. 32 plus 16. 48 trains are required totally to service the city. Brilliant, brilliant, brilliant set. Super tough. Super tough. The entire set is super tough. I made so many different mistakes. I forgot the waiting time at the junction. I forgot the fact that the train started 6, 6:15, 6:30. They threw a spanner into the works. The waiting time was very annoying. I consistently made mistakes with that and found answers that were not there in the choices. Lucky enough. The proper pain. The management of a university hockey team was evaluating performance of 4 women players, Amla, Bimla, Harita and Sarita, for their possible selection in the university team for next year. For this purpose, the management is looking at the number of goals scored by them in the past 8 matches, numbered 1 through 8. Should be the only metric, but hey, this is a puzzle, not a real selection scenario. In the 8 matches, each of them had scored at least 1 goal. No 2 players had scored the same number of goals. 8 matches, 12 goals. Each person has scored at least 1 goal. And no 2 people have scored the same number of goals. Nice. The following facts are known about the goals scored by these 4 players. All the questions referred only to the goals scored by these 4 players. Other goals we don't care about. Only 1 goal was scored in every even numbered match. Match 2, 4, 6, 8, 1, 1, 1, 1 goal. So 1, 3, 5, 7 should add up to 8 goals. Totally 12 goals. Harita scored more goals than Bimla. The highest goal scorer scored in exactly 3 matches, including match 4 and 8. Match 4, match 8 and 1 more. Bimla scored a goal in match 1 and 1 each in 3 other consecutive matches. So Bimla scored at least 4 goals. And Harita scored more than Bimla. Lovely. I think this is very interesting because total goals is only 12 and each of them scored at least 1 goal. They have 1 plus 2 plus 3 plus 4. That adds up to 10. The least combination possible of distinct numbers. We know that no 2 players have scored the same number of goals. You need to go to 12. You can have 1, 2, 3, 6. 2 more there. Or 1, 2, 4, 5. 1 more here, 1 more here. I cannot do it without 1, 2. I have 1, just leave out 2, 3 plus 4 plus 5 is 12. So without 1 and 2, I cannot do it. 1 and 2 have to be there. 1 and 2 add up to 3 goals. The remaining 2 should add up to 6 goals. Either 3 and 6 or 4 and 5. Brilliant. So I know straight away that my goal combinations are 1, 2, 4, 5 or 1, 2, 3, 6. One of these 2. I know Bimla scored at least 4 and Harita scored more than Bimla. That means Harita should have also scored more than 4 or at least 5. So 1, 2, 3, 6 is ruled out. It's only 1, 2, 4, 5. The number of goals scored, you've got that. Harita scored 5, Bimla scored 4. And Amla and Sarita have scored 1 and 2 in some order. Nice. An equal number of goals were scored in match 3 and match 7, which was different from the number of goals scored in match 1 or match 5. So for even numbers, we know 1, 1, 1, 1. Odd numbers, we know this one funda. The match with the highest number of goals was scored was unique and it was not match 5. The highest number is there in only 1. So we cannot have a scenario where number of goals the highest is 3. We have 3, 3 and 1, 2. The highest number was scored in only 1 game. Not the highest number was not scored in 2 games. I think we should capture the data in some form and then attack this. Right? So 1 plus 2 plus 3 plus 4 is 10. We want to go to 12. It's either 1, 2, 3, 6 or 1, 2, 4, 5. 2 people have scored 1 and 2. We know Bimla scored 4 or more. And Harita scored more than Bimla. Or we know Harita scored 5 and Bimla scored 4. Only 1 goal was scored in every even numbered match. So this is 1, 1, 1, 1. Harita scored more goals than Bimla. Bimla scored a goal in match 1 and 1 each in 3 consecutive matches. Match 1, Bimla scored 1 and some consecutive matches she scored 3 consecutive matches. So Bimla scored at least 4. That means Harita scored at least 5. So Bimla should have scored 4 totally. Harita should have scored 5 totally. And this is 1 and 2 in some order. The highest goal scorer scored in exactly 3 matches, including match 4 and 8. Highest goal scorer is Harita. So she scored in match 4, which is 1, and in match 8, 1. So in some other match, she should have scored the third match, she should have scored 3 goals. Harita alone scores 3 goals in some other match, right? Which means that some other match is not M2, some other match is not M6, In these two, she has not scored. Harita scored 1 goal here. Other 3 have not scored here. Harita scored 1 goal here. Other 3 have not scored here. Nice. So Bimla scored 1 goal in match 1 and 3 goals in consecutive matches, which means we can fill this also. This is 1, this is 0, 0. We don't know these. Lovely. Harita scored 3 goals in some one match in either M1, M3, M5 or M7. One of those games, Harita scored 3 goals. That much we know. An equal number of goals were scored in match 3 and match 7. Nice. Equal number of goals in match 3 and match 7, which was different from the number of goals scored in either match 1 or match 5. So, match 3 or match 7, equal number of goals, which is different from this. Match 1, 3, 5, 7 add up to 8. So, match 3, match 7 could be 1 and 1. So match 1 and match 8 could add up to 6, totally 8. Or match 3 and match 7 could be 2 and 2. Match 1 and match 5 could add up to 4. Right? Or match 3 and 7 could be 3 and 3, in which case 1 and 5 should add up to 2, put together 2. So, the number in which the highest number of goals was scored was unique. Highest number is unique. So if this were 2 and 2, it cannot be 2 and 2, it should be 3 and 1. This was 1, 1, cannot be 1, 1, 2, 4 is possible, 4 being the highest number. 3, 3 cannot be the highest number, so this is ruled out. So match 3 and match 7 could both be 1 or could both be 2. Cannot both be 3. That's not possible. Both being 3, 3 is not possible, because then there will be 2 goals only remaining for the others. Lovely. So we can use that and say match 3 and match 7 could be both 1s or both 2s, and then fill out the remaining. Right? The match in which the highest number of goals scored was unique and it was not match 5. So match 5 was not the one where the highest number of goals was scored. So match 1 should have been the one where the highest number of goals should have been scored here. And then we fill out the rest. Lovely. So we have 2 possibilities where the highest number M3 and M7 could both be 1. M3 could be 1. M7, sorry, oopsie, filling it in the wrong place. M3 could be 1. M3 could be 1 and M7 could be 1. Nice. In which case M1 and M5 would add up to 6. It's different from M1 or M5. It cannot be 1 and 5. It's going to be 5. It cannot be 1. That's ruled out. 3, 3 is not possible. It will be same. So it should be 2, 4. The maximum number of goals scored was unique and it was not match 5. So this should be 4. It should be 2. The other possibility is M3 and M7 being 2 each. M1 being 3 and M5 being 1. 2 different from M1 or M5, totally 3. So far so good, everything works nicely. So there are 2 possibilities here. The 2 equal ones could be 1 and 1 with 4 and 2, or the 2 equal ones could be 2 and 2 being 3 and 1 totally. Now we know that Harita has scored 3 goals in some one match. Look at the goal numbers: 4, 1, 1, 1, 1, 2, 1, 1, 1, 1. Only this match could be 4. Yes, this will be 3. These two will be 0, 0. This is 3, 1, 2, 1, 1, 1, 2, 1. Nothing else. Only this has 3 goals. But if Harita were 3 here, this will add up to 4 goals because Bimla has definitely scored. So this is ruled out. Not even possible. So we can ignore that and say this part is ruled out. I've written on the other way around. This part is ruled out. Only this works. because Harita could not have scored 3 goals in any game. Only that works. Right? So this is the possibility we have, which means Harita should have scored 3 here. This is 0. This is 0. Harita has not scored anywhere else. 0, 0, 0, 0. Only 1 goal here. 0, 0. Only 1 goal here. Only 1 goal here. So between M2, M3 and M5, Anita and Amla and Sarita have scored. Sarita and 2 and Amla and 1, or the other way around. We pretty much got exactly which games Bimla scored in, exactly which games Harita scored in. We filled everything out except these 3 between Amla and Sarita that goes through. Right? Lovely. How many goals were scored in match 7? Only 1 goal done, as we have found out. Which of the following is the correct sequence of goals scored in matches 1, 3, 5, 7? 1 is 4, 3 is 1, 5 is 2, 7 is 1, 4, 1, 2, 1. Done. Which of the following statements are true? Which of these is definitely true? Amla and Sarita never scored goals in the same match. Amla and Sarita have scored in M2, M3 and M5. Never in the same match, correct. If Amla scores only 1 goal. This is 1, 1, 1. This is true. This is true. Harita and Sarita never scored goals in the same match. Harita scores in 1, 4 and 8. And Sarita could have scored in 2, 3 or 5. This is also correct. Statement 1 and statement 2 are correct. Both are true. Nice. Lovely. Which of the following statements are false? In every match, at least 1 player scored a goal. Yeah, there's no 0 here. We could have formally excluded it by saying M3 and M7 could have both been 0 and tried to fill the remaining 8. It doesn't work at all. So both, in no game, somebody is scoring 0 goals. So in every match, at least 1 player scored a goal. This is true. No 2 players scored goals in the same number of matches. Bimla scored in 4 matches. Harita scored in 3 matches. Harita should have scored in 1. Yeah, this is also true. Number of matches, this is also true. Which of the following statements are false? Both are true. None of the statements is false. Choice A is the correct answer. If Harita scored goals in 1 more match as compared to Sarita, that means Harita scored in 3, Sarita would have scored in 2. Or that means Sarita should have scored in 2, 3 or 5. 2 of them. Amla scores 1 goal, Sarita scores 2. Which of the following statements are necessarily true? Amla scored goals in consecutive matches. No, Amla scores only 1 game. This is not true. Sarita scored goals in consecutive matches. No, not necessarily. She scored in M5 and M3, M2 and M5. Not true. Necessarily true. None of the statements. Neither needs to be true. First one is necessarily false. Lovely. Let's attack this one. Adara, Bitti, Chaya, Dhanavi, Esther and Fatima are the interviewers in a process that awards funding for new initiatives. A, B, C, D, E, F. Nice. Every interviewer individually interviews each of the candidates individually and awards a token only if she recommends funding. Nice. A token has a face value of 2, 3, 5, 7, 11 or 13. Prime numbers. I'm straight away. After I've loved to have gone after this. Nice prime numbers. I'm happy already. Right? Each interviewer awards tokens of a single face value only. So 2, 3, 5, 7, 11, 13. So it could be that Amla gives only 2s, Chaya gives only 11s, Fatima gives only 7s, something like that. Once all 6 interviews are over for a candidate, the candidate receives a funding that's 1,000 times the product of the face values of all the tokens. So 2 into 3 into 7 into 1,000. 5 into 7 into 11 into 1,000. 13 into 3 into 5 into 11 into 1,000. You're getting approval, you get some points, you multiply all of them, multiply by 1,000, that's the amount you're getting. Oh, brilliant. So product also, I'm loving this. For example, if a candidate has tokens with face values 2, 5 and 7, then they get a funding of 1,000 times 2 into 5 into 7, 70,000. Lovely. Pragya, Kahira, Rashida, Smera and Tantra were 5 candidates who received funding. The funds they received in descending order were 390,000, 210,000 or 390,000, 390. So 2 and 5 are there. 3 is there. 13 is there. 210,000, 210, 2 into 5 is there. 3 into 7 is there. 165, 3 is there. 5 is there. 11 is there. These are not there. 77,000 is just 7 and 11. 66,000, 2 into 3 into 11. Nice and simple. Remove the 3 zeros. Factorize them, prime factorize them. Note down the prime. Wherever there's a 0, 2 and 5 are there. Nice and easy. 390 and 210 have 2 and 5 both. 165 has a 5 but not a 2. 66 has a 2 but not a 5. Fill in the remaining numbers we've got. We are getting somewhere. Brilliant. We fill this up completely, neatly, thoroughly. The following additional facts are known. Fatima awarded tokens to everyone except Kahira. Fatima just giving away tokens except Kahira. So which numbers have, so there's a 2 in every number. The 2 numbers don't have a 2. 4 numbers have a 3. Only 1 number does not have a 3. 2 missing here, 3 missing here, 2 here, 4 here. Lovely. So Fatima is this. Fatima gives to everyone except Kahira. She doesn't give to Kahira. So this should be Kahira. Fatima has token 3 with her. Of the 5 numbers that we are given, 4 are multiples. So there's a 3 here, there's a 3 here, there's a 3 here, there's a 3 here. There's no 3 only in 77. So Fatima is given token to 4 out of the 5 candidates. And the one she's not given to, that is Kahira, Q. While Adhara awarded tokens to no one except Pragya. Only 1 tick should be there. 3 ticks, 4 ticks, 3 ticks, 2 ticks, 3 ticks. Only 1. Lovely. So Adhara gave tokens to no one except Pragya. This should be Pragya. So only one person, only one of the numbers, the multiple of 13. That the multiple of 13 has gone to Pragya. That has been given by Adhara. Nice. Rashida received the highest number of tokens that anyone received. So there are 4 tokens here. 4 here. 1, 2, 3 tokens here. 2 tokens here, 3 tokens here. Highest number of tokens received is 4. Should be Rashida. The 2 people have got 4. This or this, one of these 2, but that is Pragya already. This is Rashida. But she did not receive 1 from Esther. So she did not receive from 2 of these 2. This is Esther. Oh, brilliant. We've got PQR and EFA. You can find these 2 or one of those 2. You're through. So we've done this also. Rashida received the highest number of tokens. Did not receive from Esther. BT awarded a token to Smera but not to Kahira. To Smera but not to Kahira. Which is Smera. There should be a tick. So it could be this. No, but that's taken. It could be this. This could be BT to Smera and Kahira, or it could be this. Not this. This also works, but that is definitely Fatima. 2 possibilities. I'm a little worried here. 2 possibilities. While Dhanavi awarded a token to Kahira, but not to Smera. A tick here. So one of these 2, but a cross here. So it could be this or this. Nice. Any which way, this is Dhanavi. Kavira, but not to Smera. Smera could be this or this. Right? And then it could work the other way around. Nice. So let's put in Dhanavi and then worry from Dhanavi onwards. Right? So now there are 2 possibilities. We erase everything. This is Dhanavi. Right? And then I can say BT awarded a token to Smera but not to Kahira. Kahira should be a cross and Smera should be a plus. So this could be Smera, this could be BT. That is one possibility. In which case this would be T and this would be C. That is one possibility. Or we can say, hey, this is Smera, BT awarded to Smera but not to Kahira. So we could have a scenario where this is Smera, this is BT, in which case this would be T, this would be C, everything would be satisfied. So two possibilities that exist, captured both of them here, where it could say, we select this to be BT, that means in which case this will be Smera, or we say this is BT, in which case this would be Smera. So the third column, third row could be BT and Smera, or the first column, fifth row could be BT and Smera. Two possibilities. The remaining is C, which I think is Chaya, or a T, which the name I've forgotten. It doesn't matter. How many tokens did Kahira receive? Kahira, there's no ambiguity. This is clear in both cases. We know what is Kahira. 2, done. Who among the following definitely received a token from BT but not from Dhanavi? Not from Dhanavi. So we're looking at not from Dhanavi. Let's see this. So Dhanavi is given to two people. Receive a token from BT but not from Dhanavi. So it's one of PTS, one of these three. Received from BT for sure. In both cases, Pragya qualifies. Not T in this case, not S in this case. So only P works, because it cannot be S, because this were the case, then it does not receive from, definitely receive a token from BT but not from Dhanavi. BT, not Dhanavi, that could be S. BT, not Dhanavi. Could be S. BT, not Dhanavi, that could be S. BT, not Dhanavi, BT, not Dhanavi. Okay. T, both cases BT is not giving to T. So it could be BT but not from Dhanavi. It could be P or it could be S. Let's see. Only P is there, S is not even there. Lucky enough for us. P or S both works, but only P is there, S is not there. We're happy with it. How many tokens did Chaya award? 3. Both cases 3. Chaya and B are, these are the ones that are ambiguous. Chaya gives 3 like this or 3 like this. Could be either 2 or 5, but it doesn't matter. 3 tokens each. 3. How many tokens did Smera receive? This is the case 3. This is the case 3. Either the 3 which is 2, 3 and 11, or 3, 5 and 11. 3 and 11 for sure, either 2 or 5. How many tokens did Smera receive? 3. Which of the following could be the amount of funding that Tantra received? Tantra could be either 165 or 66. One of these two. 166,000 or 165,000. Both are possible. Okay. Lovely.